Okay, welcome back. In the last video, we were trying to complete this current land cover table. We wanted to do it for Marta Pura and for the total. And I've just filled in the numbers for Marta Pura. And just looking at that, the first thing I was able to infer is there's absolutely going to be no point taking the average percentages across the three in order to compute some kind of estimate for total, because you can see Woody Savannas is 92% here, 27% here, and 22% here, and the average is not going to be meaningful at all. So it's good to probably just look at land cover classification within each of those forests, but not as a whole. Right. So I'm going to go and delete that column. We don't need it. Okay, great. So we have this table going, and just like that, these tables are starting to look a lot more like this. In this video, let's start creating the percentage deforestation table and the average deforestation rate tables. Okay, great. So this, for some reason, is where we're just checking the 2010 land cover type. And I don't really think I need to dabble with that just yet. Here we seem to be looking at computing the percentage forests across all these different years, and then we track the year-on-year change. I'm just trying to see what the significance of column equal to 0 is, where I actually use that. I want to make sure that what I capture Okay, looks like we're trying to add up all of these 5 land cover types, because we have results percentage forest that keeps rolling, and we keep adding to that if we notice that this land cover type exists. Which is really great if the data frame that we're loading from this year's list only has the one column, right? So suppose we only had the one column here, then just looking at that number would work. Otherwise, I should be looking at an average. I don't want to look at just that column. I want to look at the something I'm just changing at this point because I think this is the right way to do it. Okay, let's try this for the first one. Let's try this for Mozambique, right? For Mozambique, we now generated this percentage deforestation, percentage forests, and deforestation percentage data frame. That looks appropriate. Just to corrupt, I'm going to go and generate this now for Banaka. Average percentage forest. 2020 was 6.46. Does that corroborate to what we have here? Yes, it does. So it is actually computing the average, and that is what we should consider. So we shouldn't have been just taking the first data point there. It only applies to a case like Mozambique where we only had the one polygon. This is the more appropriate way to do it. And you can see the percentage forest was 12% in 2010 and it's coming off to only 6%. So there's deforestation and we need to go ahead and reforest that area. The story is starting to make a lot of sense. So, okay, this is now safe to run across the board. We have this for Mozambique. I will use my Max screenshotting capabilities to generate a screenshot of that. I'll just put that onto this slide because we need to see it. Just want to see. All right, it looks like we've used decimals in the past, not percentages. So people know to read that number. Great. Let's look now at. It's really good to set up Python Jupyter notebooks like that for all the analytical tasks that you want to compute because if they're repetitive, you have to keep executing it. You want as much of it to be in a workflow as possible. Okay, we're gonna have to highlight in some form that this is Benakat. So I will create a label for that there. Great. We have this now for Supanjariji. You can see there's deforestation from 85% to 72% in 10 years. Obviously now we're in 2023. We need to look at a more recent land cover map. We'll get that when we work with Dynamic World, which probably could be more accurate also because it's a lower scale, but I think 500-meter resolution still works compared to 750-meter resolution we were using. Okay, we have that for Supanjariji forest now. All right. Great. So just like that, we've created this. The next piece here is looking specifically into the 2020 files, 2016 files, etc., and kind of deriving the difference between 2020 and 2011, 2020 and 2016 to get the 10 and 5-year deforestation rates and the average annuals. Right? So that's what we're trying to do here. Negative sign means deforestation and positive sign means that there's been afforestation rate. So let's generate this. This number corresponds to the polygon that we have right above from the data frame that we have right above here. So this is for Martapura. Right, so we start in reverse here. Okay, opposed to doing it that way, I'll just copy the text, which you can get into a different color sometimes, which is useful. And then that size. So this will repeat across the board. So we'll put it up there. We'll say Marta Pura. And probably so are the other numbers. So I have a better idea. Let's do this as a table where purely in the interest of better presentation, I need to do a few things like change the text wrapping so we get the most space from it. Right, so this is, we're doing this for a few columns, but we want to have average deforestation rate. We know that. We want to have the 10-year deforestation rate, and we want to have the 5-year deforestation rates. Right? And we want to have this for, and we want to have this for Benacat, Supanjali, and Marta Pura, like that. And maybe we insert, insert a row below that we can just put that as a footnote. We're done. So this is what we're trying to create. Last, we don't need the last column, and we'll just center all of that. We're done. Hold. All right, so this last set of numbers is what we're after. Just look at that. The 10-year deforestation rate is 45%. It's heavy, so it's really good to be informed about this before any field work commences. Okay, great. So now we're going to execute the same thing for Supanjali. We got that one. Now we have this. So we're working with Supanjali, so we can start updating these numbers. Sorry, negative sign is deforestation. So where you saw positives, you're actually looking at afforestation. Just going to run that for Banakat for these numbers. Finally, we want to do this for Mozambique, and that's just one polygon there, so we can just retain this as is. We'll just change the color so we can distinguish it from the other elements. We'll leave it there. So great, just like that, we've slowly bringing this slide closer and closer towards this. The only thing we then need to now do is generate biomass density estimates and then talk of red plus and ANR potential. We're doing well, so I think see you in the next video where we just solve for the last two elements.